require more time. So like I said, how quickly this goes and how much work time we have today, if we have any, will be dependent on you guys talking to me. So let's look at number 1. It says solve by using square roots. Analyze it. Tell me what you do. Add 81. Sounds like a good plan. Square root of both sides. What do you have to be careful about? Well, what's the square root of 81? Is that going to get you all the points? Why? Plus or minus. Yeah, you have to remember whenever you physically write a square root symbol down, you have to do the plus or minus piece. All right, well, that should have helped everybody with number 2. What do you do first? Absolutely. Next. Divide by 4. Does that work out nice? Punch it in. Negative 18. Square root. So don't forget your x equals plus or minus. Negative square root of 18. What do you see? Square root of negative 1. Anything else about 18 that would be helpful? 9 and 2, perfect square. What goes into that is 9. Okay, so let's simplify that. What's the square root of 9? 3. Square root of 2, something we're going to be able to do nicely. Okay, so 3 square roots of 2. I. Good. Good, good, good. I is the square root of negative 1. If some of you are still having trouble with the I thing, when you get your test tomorrow, start like this. You know, write that down right away. I is the square root of negative 1, and I squared equals negative 1. You know, and just keep referencing that whenever you deal with anything imaginary. Oh, completing the square. Now, yesterday, you told me you were just fine with completing the square, and we didn't need to do any extra examples at the end of the lesson. So I hope somebody can tell us how we're supposed to complete the square. Oh, good. Jameson remembered. Little bitty formula. B over 2 squared. What's B, everybody? Negative 12. So negative 12 divided by 2 squared will be negative 6 squared, which is 36. There it is. So that question is just going to test, do you remember the little formula, B over 2 squared? That's how we complete the square. But your x squared has to have a 1 in front of it to do that. So this one says solve by completing the square. Is there a 1 in front of the x squared? Beautiful. So do you remember what the first step should be? Move the 7 out of the way. Exactly. Get that 7 out of the way. That is not a perfect square. So how do we find the right one? 16 divided by 2 squared. And remember, it's a good idea to write that math down because you're going to need it later anyway. So 16 divided by 2 is 8, and 8 squared is 64. So we have to add 64 to both sides. 7 plus 64 is? But more important, we just made ourselves a perfect square trinomial. X plus 8, exactly. You want to remember, what did we square to get 64? And that was a positive 8. Oh, we're so close now. How do we solve it? Square root. Good. X plus 8 equals plus or minus the square root of 71. Oops, it didn't take my 7. 71. Any perfect squares that go into that nicely? 64, 49, 36, 25, 16, 9, 4? Nothing? It is prime. Nothing. Okay, so we finished it up by x equals -8 plus or minus the square root of 71. And we did all we could. And we got a perfect answer right there. Beautiful. But B is not ready for completing the square. What's wrong with it? Doesn't have what, Simon? It has a negative in the front. That is bad. You can't have a number or even a negative out in front. How are we going to get rid of that? It's even easier than that. Multiply or divide by a -1. That's all we have to do. So basically all we do is just change all the signs. That's it. 0 divided by -1 is still going to be 0, so that's not going to do anything over there. Well, now this is just like this problem we just did. So what do we do first? Add 26, get it over on the other side. Next. 14 divided by 2 squared. Okay, 14 divided by 2 is 7 squared. Okay, that's 49. (26 plus 49? 75. That's kind of a nice number. Something squared. What's the something? X plus 7. Then square rooty toot toot. X plus 7 equals plus or minus the square root of 75 unless we can find some perfect square business in there. 25. 3 times. So x plus 7 will equal plus or minus 5 square roots of 3, and we are almost done. We sure do. And one's an integer and one's a radical, so we can't actually do the math. We just put them both on the same side and say -7 plus or minus 5 square roots of 3. Beautiful problem. Beautiful. So now, test-taking strategy. Been working with square roots. We've been completing the square. So either they're going to change topics or we're going to have to complete the square. We have to complete the square because we need to put these in vertex form. And vertex form looks like that. Well, that's our parentheses squared. We've got to complete the square. Take a look at A. First step. This is no different than what we were just doing. Move the 11 over. It's not a perfect square. The other thing to check is there a 1 in front of the x squared? This time we're good. So now what? B over 2 squared. What's B? So 8 over 2 squared is 4 squared, which is 16. Okay, so there's a little math we can do on the left because we can put the two integers together. That's going to be y plus 27 equals something squared. X plus what? 4. Yeah, that's what we squared up there. Okay, now what? Well, this is what we needed to happen. We just move anything back. So y can be by itself. So how are we going to move plus 27 back? That's exactly what we're going to do. And notice the 27 was not in parentheses. We can't put it into the parentheses with what they have already. We just have to tack it onto the back and walk away, which is good. It means less math. We just move it back over. Now, they didn't ask for this, but on most ACT MCA tests, they're going to say, what's the vertex? -4, -27. You can find it because we have it in vertex form. All right, let's look at B. This one looks a little harder. What was the first step with all of them that we've done so far, except one? Okay, it does have to have a 1. Now, we can do this two ways. We could divide everything by 2 first, and then move, well, it'll be a -2 at that point. Or we could move the -4 over now, and then divide by 2. The easier way is to actually add the 4 first, and then divide by 2, if you can remember that you have to divide by 2. It's going to save you some math. But we have to divide by 2. That's a biggie. We have it ready to do what? B over 2 squared. Yeah, we have to complete the square. We need this to be parentheses over here. So what's B? 4. 4 over 2 squared is 2 squared, which is 4. Cool. Now the right side is the one that doesn't take too much thinking. What's going to go in there? X plus 2, that's what we squared. Now, why does the left side take more work? Because it's a fraction. And with fractions, if you want to add something, you have to have a common denominator. So we have to figure out, I didn't give myself enough space, I'll put it over here. Y plus 4 over 2 plus, how do you write 4 with a 2 on the bottom? You do. So if you've got a 4 over 1, you multiply by 2 on the top and the bottom. That'll be 8/2. Well, now we can put them together. Y plus 12 over 2 equals the x plus 2 squared. We're almost done. I know it looks bad, but we are almost done. I'm going to see if I can scoop this down some. Give myself a little more room. There we go. Because now all we have to do is move the stuff back over that's sitting with the y. So what should we move back over first? Yeah, the 2. I don't want a fraction anymore. I want to get rid of it as quickly as I can. So I'm going to multiply both sides by 2. But again, the 2 is not in the parentheses, so we can't distribute that 2. It's just going to stay in front. And then y is not quite by itself yet. What do we need to do? Subtract 12. Those that are on their phone, get that phone turned off and put it away. This is a big day. Don't want to have to take your phone. And our vertex, if they asked us, but they're not, would be -2, -12. We could tell them easily with that form. Everybody okay with that? All right, so again, in order to complete the square, it has to be a 1x squared. If it's not, then we have to take steps to get it to be. That was a lot of completing the squares, so eventually we got to change into something else. The next section was about the quadratic formula. So solve using the quadratic formula, leave answers in simplified radical form. So let's take a look. Is A ready to go into the quadratic formula? What's wrong with it? Gotta have a 0. Yep, that's right. To use the quadratic formula to solve, we have to have a 0 on one side. Well, then we need to find A, B, and C. What's A? 3. What's B? -5. What's C? negative 1, and we sing a little song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, Cedarholm, so formulas we need to have down for this test. You need to know the square root of negative 1 is I. You need to know that I squared is negative 1. You need to know b over 2 squared for completing the square. And you need to know the quadratic formula. So let's see what we have here. X equals negative of negative 5 is 5, plus or minus the square root of negative 5 times negative 5 is 25, minus 4 times 3 times negative 1, all over 2 times 3, which is 6. And now this we've talked about before. If you don't want to do any of that math under the radical in your head, you don't have to. You can punch it into the calculator. In fact, I'll do that this time so everybody can see this. 25 minus parentheses 4 times 3 times negative 1. 37, didn't have to do anything. Okay, things we might have to do. We might have to simplify our radical. 37. Any perfect squares going to go in that? No dice, huh? Okay. We might be able to reduce all the integers. As long as every integer, and there's a 1 in this position, could be reduced by the exact same thing. This one's done. There's nothing we can do with it. It's finished. So we put it in the formula, and it's done. Let's try this one. That does not look right. What's wrong with b? Let's add the x squared. X squared plus 6x minus 5 equals 0. Then we find a, b, and c. What's a? 1. That's a nice number to work with, isn't it? How about b? And c? And x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to need negative 6 plus or minus the square root of 36 minus 4 times 1 times negative 5 all over 2 times 1, which is 2. And let's see. Yeah, 56, because it'll be 36 plus 20, square root of 56. Square root of 56. Perfect squares will go into 56. What are you thinking of? 14 and 4? Sounds good. Let me do it up here so everybody can see. That's good. Let's split it. So x equals negative 6 plus or minus the square root of 4 and the square root of 14. Oops, got carried away with my ones. Over 2. And the good part of that is we know the square root of 4 is 2. Square root of 14. We simplify that anymore? No go, right? Nothing else? Okay. Can we take something out of all those numbers? Oh, they are divisible by 2, aren't they? So, again, you can factor it out. Oh, let's do it this way. Or you could just divide both of them and kind of do it in your head. And say negative 6 divided by 2 is negative 3. 2 square roots of 14 divided by 2, the 2's would cancel out. Either way, doesn't matter. But I always try to show you that canceling is a form of division, and in order to cancel, we should really see multiplication. So far, so good? All right. Oh, yep. A little farther. Anybody else need more time? Sorry, I forgot to ask. Evaluate the discriminant. Cedarholm, you said we already had all the formulas memorized. You do. X equals negative b plus or minus square root b squared minus. Oh, it's b squared minus 4ac. That's the discriminant. Don't put the square root thing on it. That's not the discriminant. The discriminant is b squared minus 4ac. So evaluate the discriminant and then tell how many and what type they're going to be. Oh, well, that came from the quadratic formula. So we're going to start the same way. We're going to make sure it equals 0. And we're going to write down a, b, and c. And then we'll just put it in b squared minus 4ac and see what we get. Let's see, negative 12 squared is 144 minus 4 times negative 3 times 1. If we don't want to do any of the math, we'll grab a calculator and say, calculator, I would like you to do negative 12 squared minus parentheses 4 times negative 3 times 1. And it says 156. So that is our discriminant. That goes up here. And it was positive. So how many solutions are we going to get? 2. Are they going to be real or are they going to be imaginary? They're going to be real. Because this is when you want to remember the square root goes over the top of this in the quadratic formula. The square root of 156 is something we can find. It doesn't have a negative in it, so it's going to be 2 reals. All right, next one. Is it ready to go? Got a 0 on one side? Okay. A is 4, B is 4, C is 1, and we need 4 squared is 16 minus 4 times 4 times 1. Yeah, it's going to be 16 minus 16. That discriminant is 0. How many solutions? Just 1. And the type? Real, because we know what the square root of 0 is. It's 0. So we can still find it. How about C? Is that one ready to go? Equals 0 again. A is 4, B is negative 8, and C is 7. And so we'll have 64, because negative 8 squared is 64. Again, you wouldn't have to do that math in your head. Use parentheses, put it in your calculator. Minus 4 times 7. That does not look like good news. So again, you could just parentheses, negative 8, parentheses squared, minus parentheses 4 times 7. Negative 48. How many solutions? 2. What type? Both imaginary, because it would be the square root of a negative 48. So these will be imaginary. And we've got it covered. Notice how each one is a little different. You know, on the test, we want to make sure you understand each and every one of those. So if we end up with something that's positive, 2 reals, 0, 1 real, and negative 2 imaginary. Oh, a word problem. No, this we absolutely need to do. If we don't get to the stuff with I, I'm not worried. You guys have been doing great with I, but we really need to talk through the word problem. Because she's math-minded. Susie throws a baseball up into the air. The ball leaves her hand when it is 4 feet above the ground. The height h of the ball in feet can be written as a function of time t in seconds as h equals negative 16t squared plus 40t plus 4. Will the ball reach a height of 30 feet? I would ask myself, so where do I put the 30? H. Well, we just need to know if this has an answer. And that's what we just did. Test-taking strategy. We just did the discriminant. So if our discriminant comes out to be negative, we can put no. If it's anything else, then we have to put yes. But that's not ready to go into b squared minus 4ac. What's wrong with it? That's gotta go. Now we can say A, B, and C. And some of you might be saying, you know what, I would have moved the negative 16t squared and the 40t and all of that over. You can do that as long as you do it correctly, because the discriminant, it doesn't matter whether or not we have a negative in front. So b squared minus 4ac will be 40 squared minus 4 times negative 16 times negative 26. Whew! It's not looking good for Susie. Alrighty, 40 squared in parentheses minus parentheses 4 times negative 16. Why do I keep hitting division? Times negative 26. Uh-oh. Susie gonna reach 30 feet? Nope, those are imaginary solutions. Will it reach? No. But we have to have the math to back it up. You know, we can't just 50-50 this. I'm not sure. I'll guess. I'll flip a coin. Hey, she didn't make it to 30 feet, but notice this doesn't say will she make it. It says when will the ball reach at that 15 feet? I don't know. We would have to think about that after we find the answer here. So now we need 15 equals negative 16t squared plus 40t plus 4. But we're going to have to do the entire quadratic formula this time, because they said there are answers. We got to find them. So we'll subtract the 15 from both sides. 0 equals negative 16t squared plus 40t minus 11. And then we'll write down A, B, and C, and we will find these solutions. So A is negative 16, B is 40, and C is negative 11, and X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So why not complete the square? It's got a negative 16 in front of the squared term. That would give us fractions, and most people will not be happy about that. So probably faster for everybody to do it this way. So negative 40 plus or minus the square root of 40 times 40 is 1600. Again, you wouldn't have to do that in your noggin if you don't want to. Minus 4 times negative 16 times negative 11. All over. 2 times negative 16 is negative 32. All right, so let's see what we have underneath that massive square root. We have, let's just assume you didn't want to do 40 squared in your head. Parentheses 40 parentheses squared minus parentheses 4 times negative 16 times negative 11. 896. If you're going to ask somebody, when will the ball reach a height of 15 feet? And you say, well, it'll reach a height of 15 feet at negative 40 plus the square root of 896 divided by negative 32. They're going to look at you like you're nuts. We actually need to figure out what these are. So we actually do the math. Negative 40 plus second square root 896 parentheses. Get my answer. Divide by negative 32. So at 0.32, well, 31 seconds with rounding. Let's just go there. But there might be another answer there too. Negative 40 minus second square root of 896, parentheses, enter, divided by negative 32. There is another answer. 2.19 seconds. So she's got a strong enough arm that she can throw it up and it's going to cross 15 feet and it's going to go up a little bit and then it's going to come back down. And she'll hit it twice. So expect to do something like that on the test. And now I go, because that's the stuff we had to get through. Now anything from here is just gravy on the taters. I don't know if you want to go right now, if you want to try and wait. It's however you feel about the eye stuff. It will be recorded. Okay. You ready? Let's deal with the imaginary stuff. Oh, what time are we out of here today? 53? Hey, we might be able to finish this, huh? Okay. Find the remaining problems, simplify, and like it says, be sure to write your answers in standard form. So when I read this, I remember it's got to be real part plus some number and then an I to be in standard form. Square root of negative 25. You already done with that one? Square root of negative 1, square root of 25, 5i. Yeah. Negative 72. Going to split that into the square root of negative 1. Biggest perfect square that goes into 72. 36. Twice. So we'll have the I, and this will be 6 square roots of 2i, because we need our answer in standard form. So let's put the I stuff in the back. 11. This is the one where people are going to make mistakes, and they're going to, well, they're really going to be mad at themselves. The first mistake some people make is they see the parentheses and they do FOIL right away. Do they want us to multiply in number 11? No. This says subtract. What's the other mistake that's going to be made? You forget to distribute the negative, then you're in trouble. So distribute this as if it were a negative 1 times everything. And then combine your like terms. 5 minus 7 is negative 2. Negative 8i minus 3i. Negative 11i. It's in standard form. So just because you see parentheses, don't jump to conclusions and go, oh, I've got to do FOIL. You know, look between the parentheses. What do they want you to do? All right, in 12, do I have to be quite so cautious? It's addition. So basically, we could write it without those parentheses. They just wanted us to see it's two complex numbers being added together. And then combine like terms. What do you get? There it is in standard form. All right, number 13. What do we do with that one? Yeah, now we do FOIL. There's no plus or minus between that one, so this one is going to be FOIL. So first times first, 18. Outside times outside, plus 30i. Inside times inside, minus 6i. Last times last, minus 10i squared. Give me a light bulb moment. I squared is negative 1. Something else you saw right away you could do. Combine the two middle terms. So 18 plus 24i minus 10 times negative 1. And you go, oh, that's going to be a plus 10. 18 plus 10 will be 28. And we've got it in standard form. Cool. 14. You guys didn't have questions on these. No, just the one that had the goofy radical in the denominator today. So apparently this went really well in the homework. All right, for number 14, what are we going to multiply the top and the bottom by? Good, 4 plus 5i. We have to use the conjugate. And what you do to the bottom, you have to do to the top. But my focus would be on that denominator first. Make sure everything's going to work out nice on the bottom. So first times first is 16. We don't have to do outside times outside and inside times inside. That's the reason we did the sum and difference pattern. Last times last, minus 25i squared. What's the light bulb moment? I squared is negative 1, so that's going to make it 16 plus 25, which is 41. So that's good news. That means we should go back and carefully do the numerator. Yeah, that's fine. And that's just distributing a 7, so 28 plus 35i, 28 plus 35i, 28 plus 35i, except that's not in standard form. Remember how to do that? Can anybody give me the first fraction you'd see? 28 over 41 plus 35 over 41 I. 41, that's kind of a nasty number. Are we going to be able to reduce either one of those? That's done. Okay. Last one. Take a look at 15. Thoughts? 4 plus 3i, top and bottom. With a focus on the bottom. Let's make sure that works out to a real number. First times first is 16. We did the plus and minus, so we don't have to do outside times outside, inside times inside. Last times last is minus 9i squared. So what does that tell you? It's going to be, yeah, because this is going to be negative and negative. It'll be plus. Ooh, that's a nice number. Got a nice little 25 down there. Now, carefully do your FOIL on the top. And then we'll check and make sure everybody has the same thing. So I have 12 plus 9i minus 4i minus 3i squared. Everybody match that? Okay, now do your light bulb moments. So combine your two middle terms. And remember that I squared is negative 1. Is that one done? No. Now, this one, if we just put it in standard form, we're going to be able to reduce really nicely. So 15 over 25 plus 5 over 25i. We realize, oh, we can take a 5 out of that stuff. 3/5 plus 1/5 I. Glad I gave you that review assignment earlier. Now, I'm recording this, and I'm going to put it up. There's already one on there from a previous year, but I know we didn't finish the previous year. And one-year students had asked for another one that they could run through on their own. So if you go on to the video lessons, there's actually a B version. We did another practice test. So that would be something you could take, just a sheet of paper and look at the problem, hit pause, do the problem, and then watch the video to make sure you did it right. But don't